Hello. Today I am going to explain you the basic working principle of a basic diode, that is PN junction diode. This is the series of basic concepts of engineering. If you are new on this channel, please subscribe this channel and like this video and share as you can. Okay, let's get started. So, in this lecture, we will cover what is a diode, how they looks like, how does a diode work, and where we use them, and how to test our diode. Okay, in this lecture, we will cover what is a diode, how they looks like, and how does a diode work. In the next video, I will explain you where we use them and how they work in our rectifiers and how to test our diode. Okay, first of all, our diode is a semiconductor material, and you must know what is a semiconductor material. Semiconductor material are those material that have properties in between our conductor and insulators. Conductor are those material that have free electrons to conduct electric current, and insulator are those materials that have no free electrons and they have poor conductivity of electric current. And semiconductor material are in between the conductor and insulators. In specific condition they can conduct electric current. And our diode is a unidirectional current. Unidirectional current means it will allow current to flow only in one direction, okay, in forward bias. And PN junction, we have two different this is not a different material, this is the same material that is made up of silicon, and we can use also germanium, this is the doping. We have p type doping and n type doping. These are p-n junctions. In p type material we have majority of holes and minority of electrons. In n type material we have majority of electrons, and they work in forward and reverse bias. And we can use our diode as rectification to convert AC to DC. Okay, this is the diode, and they look like just like that. Practically, they are just like that. And this is the symbol of our diode, and this is the p-n junction material. We have two portions. One is p-type material, and the other one is n-type material. It have holes and it have electrons. Okay, one side is anode that is positive and the other one side is cathode that is negative. And in this case, this side is positive and this is our negative. And this is just a symbol of diode. Okay, if we take an example of check valve, they work. Our diode work just like an check valve. They allow current only in one direction. For example, in this valve, if the flow of water is in this direction, then it will automatically open this valve and water will flow in this direction. If water is in this direction, then this check valve will block the flow of water. Just like that, in our diode, current flow only in forward bias. In this direction, current will flow, and it will block current in this direction. In opposite direction, it will block the current. Next, we have conductor, insulators, and semiconductor. You can see here, this is our insulator. There are two different bands, that is valence band and conduction band. Electron jump from our conduction band to valence band. This is just like electron jump. If the band gap distance is very higher, then it will not conduct electric current. Electrons will not jump towards the holes and it will not fill the holes. That's why they are insulator and they cannot conduct electric current. Conductors are those material. In this we have valence band and conduction band are overlapped, and our electrons easily jump into the holes. But in semiconductor material, the band gap is very small. By adding some impurities, that is p type or n type, we can conduct electric current in our semiconductor materials. This is a pure conductor, that is copper. It have free electrons, and electric current can easily flow through a copper wire. Next, how does a diode work? This is clear now that this is a semiconductor material that is made up of silicon or germanium, and then we have p-type and n-type doping that make a junction. For example, this is our diode. When we construct it, when we add some p-type and n-type doping, then there is a diffusion will occur, because in this side we have majority of hole, and in this side there are electrons, and during its construction diffusion will occur, and some electrons jump on this sides, some electrons jump on this side, and holes will left here, and there is a region created, that is depletion region. Now, in order to pass the electric current, we have some voltages, that is zero point 0.7 voltages for silicon and zero point 0.3 voltages for germanium. They are required. They are required to break this depletion region. Okay, next we have two different modes: forward bias, when our p-type material is connected with positive and n-type material is connected with negative, then we can say this is our forward bias. But if negative is connected with p-type material and positive is connected with n-type material, then it is our reverse bias diode, and in this case it will not allow the current to flow through it, and it will block the current, and it behaves just like an off switch. Okay, this is the p-n junction. One side is anode, that is p-type. Okay, this is P type and this is N type. On P side we have majority of holes, on N side we have majority of electrons. During its construction, diffusion will occur, and some electrons jump from this side to this side and make a small depletion region. And there are holes left when the electrons jump from this side to this side. This is the inside view of a diode. Here we have a semiconductor material. This is insulated layer. This is anode and this is cathode. Now this is the forward bias. Because p type is connected with positive of battery and n type is connected with negative of battery. In this case, how does our diode work? You must know that opposite charges attract and same will repel. The same concept is used here. Now this is the positive of battery, so it have positive here, and these are the holes, and they have positive charge. Holes have positive charge, so positive charge, they will repel each other. So it will repel these holes toward the junction, and when we have voltages greater than zero point 0.7 voltages, it will these holes will jump from this side to this side, and these electrons will attract these positive charges, and now we have positive charges here, so they will attract toward the negative charge, and in this way our cycle will complete. Okay, this is the forward bias. In this case, positive will repel the holes, and these holes will jump towards the electrons, or you can say our electrons will repel these electrons. This negative charge will repel these electrons, and these electrons will jump towards the holes and cover that space, and in this way these electrons now attracted toward the positive charge, so this is the direction in which current will flow. But if we connect it in reverse, these are the VI characteristics of forward bias diode. Initially we have voltages. If we have voltages less than zero point 0.7, then this is not enough to break the depletion region, to overcome the depletion region, so current will not flow in this case. When we have voltages greater than or equal to zero point 0.7 voltages, then our current will start flowing, and when we have voltages greater than zero point 0.7, then our current will increase immediately, and these are the VI characteristics of diode. What will happen when we connect our diode in reverse bias? Here you can see this is the negative of battery and this is positive of battery. When we connect negative with positive and positive with negative, then this is reverse bias of diode. In this case, negative charges will attract the holes and positive charges will attract the electron. Okay, in this way the gap will increase. The gap will increase, and now we need more voltages to overcome this gap. Okay, in this case gap will increase and it behaves just like an off switch. One more thing, it is an uncontrollable switch because there is no control for this. If we connect it in forward bias, it will behave just like an on switch. When we connect it in reverse bias, then it behaves just like an off switch. Or we cannot say that our diode is in forward and reverse bias. When we connect positive with positive and negative with negative, then it is forward bias. If we apply voltages just like that, if we apply p material with negative 10 voltages and n side with positive 12 voltages. Now you can see that we have connected negative terminal. Let's say this is minus 10 and this is positive 12. In this case we have negative 10 and positive 12. We have two voltages that are greater than zero point 0.7 voltages that are required to overcome this depletion region. So in this case this diode is also in forward bias. But you just remember that when we have positive charge on p-type material and negative charge on n-side material, then our diode is in forward bias. This is very basic. Okay, next we have the VI characteristics of reverse bias diode. Initially, you can see that current will not flow in reverse bias diode. But when we increase the voltages from a certain level, for example, if we apply 20 voltages to diode, okay, if we apply 20 voltages or greater than voltages, then our device will damage and current will start flowing just like that, and after that our device will damage and we cannot use our diode in forward bias. It will allow the current to flow in both forward and reverse direction because our the device is damaged now, so we use it in forward bias to turn on the switch, and reverse bias to turn off the switch, and this is the limit that it can hold the voltage in reverse bias condition. Okay, next we have where we use them. Now we can discuss these slides in our next video. So it is enough for today's video. If you like this video, you can subscribe our channel and like this video as you can. Okay, and share this video as much as you can. Okay, see you in the next video. Take care. Allah Hafiz.